Not only is it able to generate other pixels spatially, because it's aware of what the color should be, it has been trained on a supercomputer back in NVIDIA, and so the neural network that's running on the GPU can infer and predict the pixels that we did not render. Not only can we do that, it's called DLSS. The latest generation of DLSS also generates beyond frames. It can predict the future.
Whoa!
3 additional frames for every frame that we calculate. What you saw, if we just said 4 frames of what you saw, because we're going to render 1 frame and generate 3. If I said 4 frames at full HD, 4K, that's 33 million pixels or so. Out of that 33 million pixels, we computed only 2. It is an absolute miracle that we can computationally using programmable shaders and our ray tracing engine, to compute 2 million pixels and have AI predict all of the other 33. And as a result, we're able to render at incredibly high performance.
Bad at math. That would be 31.
A lot less computation. It takes, of course, an enormous amount of training to produce that, but once you train it, the generation is extremely efficient. So this is one of the incredible capabilities
You're thinking
of
about gaming
artificial
applications, but it's not just gaming. It's for other shit.
There's so many amazing things that are happening. We used GeForce to enable artificial intelligence, and now artificial intelligence is
God damn!
Audience and fucking customer base.
Everyone, today we're announcing
gaming.
Our next generation, the RTX Blackwell family. Let's take a look.
Lock in. Ooh, I've never seen that before, chat. Look at the shape of it. Oh, my name is Optimus Prime.
Yeah, shut the fuck up.
Ultra fast G7 1.8 TB. Blackwell GPU, boom, 92 transistors, 4,000 AI flops.
Here it is. Our brand new GeForce RTX 50 series.
50
Blackwell
series.
architecture.
Holy shit. Yeah,
the GPU is just a beast.
No, thank you.
92 billion transistors, 4,000 tops, 4 petaflops of AI, 3 times higher than the last generation Ada. And we need all of it to generate those pixels that I showed you. 380 ray tracing teraflops so that we could, for the pixels that we have to compute the most beautiful image you possibly can. And of course, 125 shader teraflops. There's actually a concurrent shader teraflops as well as an integer unit of equal performance. So 2 dual shaders. One is for floating point, one is for integer. G7 memory from Micron. 1.8 terabytes.
Micron!
Twice the performance of our last generation.
Micron mentioned.
We now have the ability to intermix AI workloads with computer graphics workloads. And one of the amazing things about this generation is the programmable shader is also able to now process neural networks. So the shader is able to carry these neural networks, and as a result, we invented neural texture compression and neural material shading. As a result of that, you get these amazingly beautiful images that are only possible because we use AIs to learn the texture, learn the compression algorithm, and as a result, get extraordinary results. Okay, so this is the brand new RTX Blackwell 5090.
Blackwell.
Now, even the mechanical design is a miracle. Look at this, it's got 2 fans. This whole graphics card is just one giant fan. You know, so the question is, where's the graphics card? Is it literally this big? The voltage regulator design is state-of-the-art, incredible design. The engineering team did a great job. So here it is. Thank you. Okay, so those are the speeds and feeds, so how does it compare?
How does it compare?
I want 3 fans.
This is
Shut.
RTX 4090. I know.
This
I
is
know many of
bulky
you
as
have
shit.
one.
All I have is my computer right now.
I know it. Look, it's $1,599. It is one of the best investments you could possibly make. For $1,599, you bring it home to your $10,000 PC entertainment
What?
center.
Who's
Isn't that right?
got a $10,000
Don't tell me
PC?
that's
This
not
guy.
true. Don't be ashamed.
This guy is out of
It's
touch.
liquid
Oh no.
fancy lights all over it.
Oh no.
You lock it when you leave.
Oh no.
It's the modern home theater. It makes perfect sense.
I know
And
the
now
joke,
for $1,500 and $1,599, you get to upgrade that and turbocharge the living daylights out of it. Well, now with the Blackwell family, RTX 5070, 4090 performance at $549.
I'm
Bro, the 5070 is $550. It's 4090 performance for
Impossible
$550
without artificial
bucks.
Intelligence. Impossible without the 4 terops
There's only
of
500 total on the
AI
market, though,
tensor
available
cores.
for the next 5 years.
Impossible without the G7 memories. Okay, so
Those are gonna sell out
5070,
instantly.
4090 performance, $549, and here's the whole family. Starting from
I bought
5070
half of them
all
already.
the way up to 5090. 5090, twice the performance of
Okay, the
4090.
5090 is $2,000 though. 5080 is $1,000.
Starting, of course, we're producing at very large scale availability starting January. Well, it is incredible, but we managed to put these in gigantic performance GPUs
Stop
into a
complaining
laptop.
about the price
This
of
is
the
a
higher end
5070
GPUs.
laptop.
It's not for you. Like, why are you
For
complaining?
$1299,
It's not your product.
This 5070 laptop has a 4090 performance. I think there's one here somewhere. Let me show you this. This is look at this thing. Here. There's only so many pockets.
GPUs
Ladies
have
and gentlemen,
changed.
Janine Paul.
Your average gamer does not need
So can you imagine?
the top
We've
end
got this
GPUs anymore.
incredible graphics card here, Blackwell. We're going to shrink it and put it in there. Does that make any sense?
No, it doesn't.
Well, you can't do that without artificial intelligence. And the reason for that is because we're generating
Oh yeah, artificial intelligence makes smaller fucking fans. That makes so much sense. Yeah, it just makes the fan smaller, bro.
we generate
Absolutely.
artificial
Fuck
intelligence,
me.
all of the other pixels we have. As a result, the energy efficiency is just off the charts. The future of computer graphics is neural rendering, the fusion of artificial intelligence and computer graphics. And what's really amazing
I mean, also, I doubt he's holding a 5070, right?
is, oh, here we go. Thank you. This is a surprisingly kinetic keynote. And what's really
Of course
amazing
it's
is the
gonna be blurry.
family of GPUs we're going to put in here.
That's why I hate it
So
personally.
the 5090 will fit into a laptop, a thin laptop. That last laptop was 14.9 millimeters. You got a 5080, 5070 Ti, and 5070.
Okay, that's useless.
So,
that's
ladies and
brain
gentlemen,
dead.
The RTX
There's no
Blackwell
way
family.
you're getting into your money in terms of like efficiency
No.
of what you pay for.
No, there's no
on a
fucking way.
$3K laptop like that, no shot.
Yeah, no. This thing's gonna overheat in
buy the
0.2
lower end
seconds.
and you get a good setup at home. That's brain dead.
brought AI to the world, democratized AI. Now AI has come back and revolutionized GeForce.
15-minute battery.
Let's go to somewhere else at NVIDIA.
Yo, what the fuck? Actually true.
This is literally our office. This is literally NVIDIA's headquarters.
Literally.
Okay, so let's talk about AI.
Bro, it's the second time he does that,
industry-
but I don't get it.
Is
Yeah, I don't get it
chasing
either.
and racing to scale artificial intelligence. And the scaling law is a powerful model. It's an empirical law that has been observed and demonstrated by researchers and industry over several generations. And the scaling law says that the more data you have, the training data that you have, the larger model that you have, and the more compute that you apply to it, therefore, the more effective or the more capable your model will become. And so the scaling law continues. What's really amazing is that now we're moving towards, of course, and the internet is producing about twice the amount of data every single year as it did last year. I think in the next couple of years, humanity will produce more data than all of humanity has ever produced since the beginning. And so we're still producing a gigantic amount of data, and it's becoming multimodal. Video and images and sound, all of that data could be used to train the fundamental knowledge, the foundational knowledge of an AI. But there are, in fact, two other scaling laws that has now emerged. And it's somewhat intuitive. The second scaling law is post-training scaling law. Post-training scaling law uses techniques like reinforcement learning, human feedback. Basically, the AI produces and generates answers.
Yeah, and then the reasoning models, whatever.
Based on a human query. The human then, of course, gives a feedback. It's much more complicated than that, but that reinforcement learning system with a fair number of very high-quality prompts causes the AI to refine its skills. It could fine-tune its skills for particular domains.
I don't understand it because I watched a video about the reasoning models.
And so it's essentially like having a mentor or having a coach give you feedback after you're done going to school. And so you get tests, you get feedback, you improve yourself. We also have reinforcement learning AI feedback, and we have synthetic data generation. These techniques are rather akin to, if you will, self-practice. You know the answer to a particular problem, and you continue to try it until you get it right. And so an AI could be presented with a very complicated and a difficult problem that is verifiable functionally, and it has an answer that we understand, maybe proving a theorem, maybe solving a geometry problem. And so these problems would cause the AI to produce answers, and using reinforcement learning, you would learn how to improve itself. That's called post-training. Post-training requires an enormous amount of computation, but the end result produces incredible models. We now have a third scaling law, and this third scaling law has to do with what's called test time scaling. Test time scaling is basically when you're being used. When you're using the AI has the ability to now apply a different resource allocation. Instead of improving its parameters, now it's focused on deciding how much computation to use to produce the answers it wants to produce. Reasoning is a way of thinking about this. Long thinking is a way to think about this. Instead of
just
long
put the chip in the
thinking?
box, buddy.
one-shot answer, you might reason about it.
Just
you
put
might
the
break
chip
down
in the
the
fucking
problem into
box.
multiple steps. You might generate multiple ideas and evaluate. Your AI system would evaluate which one of the ideas that you generated was the best one. Maybe it solves the problem step by step, so on and so forth. And so now test time scaling has proven to be incredibly effective. You're watching this sequence of technology and all of these scaling laws emerge as we see incredible achievements from ChatGPT to O1 to O3, and now Gemini Pro. All of these systems are going through this journey step by step by step of pre-training to post-training to test time scaling. Well, the amount of computation that we need, of course, is incredible. And we would like, in fact, that society has the ability to scale the amount of computation to produce more and more novel and better intelligence. Intelligence, of course, is the most valuable asset that we have, and it can be applied to solve a lot of very challenging problems. And so, scaling law. It's driving enormous demand for NVIDIA computing. It's driving an enormous demand for this incredible chip we call Blackwell. Let's take a look at Blackwell.
Option-based and narrative-driven games
full production.
could benefit a lot from this. I agree with somebody in the chat then.
It is incredible what it looks like. So first of all, there's some, every single cloud service provider now have systems up and running. We have systems here from about 15 computer makers. It's being made about 200 different SKUs, 200 different configurations. They're liquid-cooled, air-cooled, x86, NVIDIA Grace CPU versions, NVLink 36 by 2, NVLink 72 by 1, whole bunch of different types of systems so that we can accommodate just about every single data center in the world. Well, these systems are being currently manufactured in some 45 factories. It tells you how pervasive artificial intelligence is and how much the industry is jumping onto artificial intelligence in this new computing model. Well, the reason why we're driving it so hard is because we need a lot more computation. And it's very clear that...
What is he looking for? What? Did you lose something?
Janine?
Bro is actually lost. Yeah, I'm high as shit up here. Oh, man, what the hell am I looking for?
It's hard to tell. You don't ever want to reach your hands into a dark place.
That is true.
Hang on a second. Is this a good idea? All right.
Don't break it. Oh my god, I literally thought that was gonna flip.
The shield, is that the size of the fucking ship they cut these days?
What is he doing?
No, stop. Okay, I'm selling my stocks. I'm not kidding. No, absolutely not.
Wait for it.
What the fuck is going on? Alright, you know what? This might be one of the best things since they fucking had Bill Gates dancing on the stage.
Sell.
Jesus Christ.
Apparently,
Somebody clap for him. God damn.
All right. This is my show and tell.
Oh my god.
This is a show and tell. So, this NVLink system, this right here.
There's no context.
This is
like, nobody knows what you're doing.
200 NVLink 72. It is 1.5 tons. 600,000 parts.
Like, the joke wasn't even set up.
Approximately equal to 20 cars. 120 kilowatts. It has a spine behind it that connects all of these GPU together. 2 miles of copper cable. 5,000 cables.
Where? I don't know what he's saying.
Manufactured in 45 factories around the world.
Bro.
We build them, we liquid cool them, we test them, we disassemble them, ship them in parts to the data centers because it's 1.5 tons. We reassemble it outside the data centers and install them. The manufacturing is insane. But the goal of all of this is because the scaling laws are driving computing so hard that this level of computation,
He's recovering from the bad joke.
our last generation, improves the performance per watt by a factor of 4.
It's a confidence dip.
Performance per watt by a factor of 4, performance per dollar by a factor of 3. That basically says that in one generation, we reduce the cost of training these models by a factor of 3.
Avengers
Or if you want to
assemble.
increase the size of your model by a factor of 3, it's about the same cost. But the important thing is this. These are generating tokens that are being used by all of us when we use ChatGPT or when we use Gemini, use our phones in the future. Just about all of these applications are going to be consuming these AI tokens. And these AI tokens are being generated by these systems. And every single data center is limited by power. And so if the perf per watt of Blackwell is 4 times our last generation, then the revenue that could be generated, the amount of
4x
generated in the data center is increased by a factor of 4. And so these AI factory systems
Holy!
are factories today. Now the goal of all of this is so that we can create one giant chip. The amount of computation we need is really quite incredible.
Are they really maxed out?
And this is basically one giant chip. If we would have had to build a
by
chip,
power?
here we go. Sorry, guys. You see that? That's
Yeah, I'm fucking blind, thanks.
Look at that. Disco lights in here.
That's pretty crazy.
He's still going with it.
If we had to build this as one chip, obviously this would be the size of the wafer, but this doesn't include the impact of yield. It would have to be probably 3 or 4 times this size. But what we basically have here is 72 Blackwell GPUs or 144 dies. This one chip here is 1.4 exaflops. The world's largest supercomputer, fastest supercomputer,
Wait, they made that
recently, this entire room supercomputer only recently achieved an exaflop plus. This is 1.4 exaflops of AI floating point performance. It has 14 terabytes of memory, but here's the amazing thing. The memory bandwidth is 1.2 petabytes per second. That's basically the entire internet traffic that's happening right now. The entire world's internet traffic is being processed across these chips, okay? And we have 130 trillion transistors in total, 2,592 CPU cores, whole bunch of networking. And so these, I wish I could do this. I don't think I will. So these are the Blackwells. These are our ConnectX networking chips. These are the NVLink, and we're trying to...
He's looking at a sheet to tell him what part, what?
Spine, but that's not possible, okay? And these are all of the HBM memories, 14 terabytes of HBM memory. This is what we're trying to do, and this is the miracle of the Blackwell system. The Blackwell dies right here. It is the largest single chip the world's ever made. But yet, the miracle is really, in addition to that, this is the Grace Blackwell system. Well, the goal of all of this,
if
of
the
course,
technology gets better
so
on
that
those,
we
though.
can. Thank you. Thanks.
I mean,
The audience is really
Is
dead.
there a
We
chair
really
I
need
could
some.
sit down for a second?
I need some hype people in the audience to get them going. Like they need to set that shit up. If you ain't got natural people clapping, you just gotta throw some randoms in the
what's happening,
audience.
man?
Mr. Beast, this
I
shit.
don't. I give
Can
up.
I have
man.
a Michelob Ultra?
Like, dude, I'm.
Yeah, it's dry ass crowd, man. They're not even.
Guys, this,
How is it possible?
Guys, 3 jokes, no hits. That's a crit.
Ultra Stadium.
This guy just got
That is.
critted like twice.
Actually
in the last 5
true.
minutes.
Coming to NVIDIA, and we don't have a GPU for you. So we need an enormous amount of computation because we want to train larger and larger models, and these inferences used to be one inference, but in the future, the AI is going to be talking to itself. It's going to be thinking. It's going to be internally reflecting, processing. So today, when the tokens are being generated at you, so long as it's coming out at 20 or 30 tokens per second, it's basically as fast as anybody can read. However, in the future, and right now with GPT-01, you know, with the new Gemini Pro and the new the 01, 03 models, they're talking to themselves, reflecting, they're thinking. And so, as you can imagine, the rate at which the tokens could be ingested is incredibly high. And so we need the token rates, the token generation rates, to go way up. And we also have to drive the cost way down simultaneously so that the quality of service can be extraordinary, the cost to customers can continue to be low, and AI will continue to scale. And so that's the fundamental purpose, the reason why we created NVLink. Well, one of the most important things that's happening in the world of enterprise.
He didn't even
agentic
intro
AI.
this, yeah.
Agentic AI basically is a perfect example of test time scaling. AI is a system of models. Some of it is understanding, interacting with the customer, interacting with the user. Some of it's maybe retrieving information from storage, a semantic AI system like a RAG. Maybe it's going on to the internet. Maybe it's studying a PDF file. And so it might be using tools, it might be using a calculator, and it might be using a generative AI to generate charts and such. And it's taking the problem you gave it, breaking it down step by step, and it's iterating through all these different models. Well, in order to respond to a customer in the future, in order for AI to respond, it used to be ask a question, answer starts spewing out.
Out of
In the
all
future,
things
you
he
ask
said
a
to
question,
analyze, really,
a whole
bro.
bunch of models are going to be working in the background. And so
That's good.
test time scaling, the amount of computation used for inferencing is going to go through the roof. It's going to go through the roof because we want better and better answers. Well, to help the industry build agentic AI, our go-to-market is not direct to enterprise customers. Our go-to-market is we work with software
What is it?
developers in
Digital
the
human?
IT ecosystem
Huh?
to integrate our technology to make possible
wouldn't need to get a bunch of, like, virtual
capabilities, just
machine
like
and
we
shit
did
to
with
do
CUDA
that?
libraries. We now want to do that with AI libraries. And just as the computing model of the past has APIs that are doing computer graphics or doing linear algebra or doing fluid dynamics, in the future, on top of those acceleration libraries, CUDA acceleration libraries, we'll have AI libraries. We've created 3 things for helping the ecosystem build agentic AI. NVIDIA NIMs,
Digital
which are
human.
essentially AI microservices all
Chat,
packaged
you're
up.
overplaced.
It
I don't
takes
give a fuck
all
anymore.
of this really complicated CUDA software, CUDA DNN, Cutlass, or Tensor RTLM, or Triton, or all of these different really complicated
just gonna get
software,
human-
and the model itself, we
humans in
package
chat
it up, we
that laugh at all my
optimize it,
jokes.
we put it into a
Hawk
container,
Tua.
and you could take it wherever
It
you
is-
like.
Shut
And
the
so
fuck
we have
up.
models for vision, for understanding languages, for speech, for animation, for digital biology.
I've played these
and
games
we have
before.
some new exciting models coming for physical AI. And these AI models run in every single cloud because NVIDIA
Where's my
GPUs are
7
now
TV?
available in every single cloud. It's available in every single OEM. So you could literally take these models, integrate it into your software. AI agents that run on Cadence, or there might be ServiceNow agents, or they might be SAP agents, and they could deploy it to their customers and run it wherever the customers want to run the software. The next layer is what we call NVIDIA NeMo. NeMo is
I
essentially
understand this.
a digital employee onboarding and training evaluation system. In the future, these AI agents are essentially digital workforce that are working alongside your employees, doing things for you. on your behalf.
Alongside.
And so the way that you would bring these specialized agents into these special agents
Yes,
into your company is to onboard them. Just
Every
like you
company's just gonna
onboard
put this
an
on
employee.
to check
And so we
productivity.
have different libraries that helps these AI
What
agents
is today's
be
fucking
trained for the type of
words per minute being
language
typed on
in
their
your company.
emails?
Maybe the vocabulary
Nope.
is unique to your
Adaptive
company, the business
salary based
process
on
is
production
different.
levels, WPM
You would
average.
give them examples of what
hey.
the work product should look like.
Adaptive
And they would try to
salary,
generate
fuck
it, and
off.
You would give it feedback, and then you would evaluate them, so on and so forth. And so that, and you would guardrail them. You say, these are the things that you're not allowed to do. These are the things you're not allowed to say. And we even give them access to certain information.
I just gave it.
So that entire pipeline, digital employee pipeline, is called NeMo. In a lot of ways, the IT department of every company
Yeah, we're
is
gonna
going
be
to
finding
the
NeMo
HR
for sure.
department of AI agents in the future. Today, they manage and maintain a bunch of software from the IT industry. In the future, they'll maintain, nurture, onboard, and improve a whole bunch of digital agents and provision them to the companies to use. Okay?
Oh,
And so
boy.
your IT department is going to become kind of like AI agent HR.
Imagine
And on top of
adaptive
that,
Goodbye,
they provide
A.
a whole bunch of
And the laws
blueprints
say
Did you just
that
say
allow
he's
the
getting
system
under minimum
to
wage
take advantage of
slash
all
IT
of this
jobs.
fully open source. And
So,
you could take it
instead of being $11 an
and,
hour,
modify the blueprints. We have
it's
blueprints
7
for
to
all kinds of
15.
different types of agents. Well, today we're also announcing that we're doing something that's really cool and I think really clever. We're announcing a whole family of models that are based off of Llama, the NVIDIA Llama Nemotron language foundation models. Llama 3.1
Say that 10 times fast.
is a complete phenomenon. The download of Llama 3.1 from Meta, 650,000 times, something like that. It has been
Something like that.
derived
Llama
and turned into
Nemotron.
other models, about
name.
60,000 other different models. It is singularly the reason why just about every single enterprise and every single industry has been activated to start working on AI. Well, the thing that we did was we realized that the Llama models really could be better fine-tuned for enterprise use. And so we fine-tune them using our expertise and our capabilities, and we turn them into the Llama Nemotron suite of open models. There are small ones that interact in very, very fast response time, extremely small. They're what we call super Llama Nemotron supers. They're basically your mainstream versions of your models. Or your ultra model. The ultra model could be used to be a teacher model for a whole bunch of other models. It could be a reward model, evaluator, a judge for other models to create answers and decide whether it's a good answer or not, basically give feedback to other models. It could be distilled in a lot of different ways. Basically, a teacher model, a knowledge distillation model. Very large, very capable. And so all of this is now available online. Well, these models are incredible. It's number one in leaderboards for chat, leaderboard for instruction, leaderboard for retrieval. So the different types of functionalities necessary that are used in AI agents around the world, these are going to be incredible models for you.
Guys, in my opinion,
we're also working with
AI
the ecosystem.
anti-cheat is needed.
All of our NVIDIA AI technologies are integrated into the IT industry. We have great partners and
It's
really
how
great
you
work
break
being done at
kernel
ServiceNow,
level
at SAP,
anti-cheats.
at Siemens.
It's the only way to beat it.
For industrial AI. Cadence is doing great work. Synopsys is doing great work. I'm really proud of the work that we do with Perplexity. As you know, they revolutionized search. Yeah, really fantastic stuff. Codium, every software engineer in the world. This is going to be the next giant
interpret
AI
input data
application.
from
next
the user
giant AI
and match it
service,
with
period is
margins
software coding.
of
30
possible
million software engineers around the world.
physical
Everybody
movement.
is going to have a software assistant helping them code. If not, obviously you're going to be way less productive and create lesser good code. And so this is 30 million. There's 1 billion knowledge workers in the world. It is very, very clear AI agents is probably the next robotics industry and likely to be a multi-trillion-dollar opportunity. Well, let me show you some of the blueprints that we've created and some of the work that we've done with our partners with these AI agents.
Multi-trillion-dollar opportunity.
AI agents are the new digital workforce, working for and with us. AI agents are a system of models
I hate
that
this voice.
reason about
I
a mission,
fucking hate it.
break it down into tasks, and retrieve data or use tools to generate a quality response. NVIDIA's agentic AI building blocks, NIM pre-trained models, and NeMo framework let organizations easily develop AI agents and deploy them anywhere. We will onboard and train our agentic workforces on our company's methods, like we do for employees. AI agents are domain-specific task experts. Let me show you 4 examples. For the billions of knowledge workers and students, AI research assistant agents ingest complex documents like lectures, journals, financial results.
Yeah, this makes sense. Yeah.
Interactive podcasts for easy learning.
Yeah, it's over.
By
Every
combining
workplace-
a UNet regression model with a diffusion model, CoreDiff can downscale global weather forecasts down from 25 kilometers to 2 kilometers.
Developers, like at NVIDIA, manage software security AI agents that continuously scan software for vulnerabilities, alerting developers to what action is needed. Virtual Lab AI agents help researchers design and screen billions of compounds to find promising drug candidates faster than ever. And Video Analytics AI agents, built on an NVIDIA Metropolis blueprint, including
It's
NVIDIA
just
Cosmos,
like
Nematron
specialized
visual language
fucking
models,
Google.
Oh my God, the
Llama
words.
Nematron LLMs, and NeMo Retriever. Metropolis agents analyze content from the billions of cameras generating 100,000 petabytes of video per day. They enable interactive search, summarization, and automated reporting, and help monitor traffic flows, flagging congestion or danger. In industrial facilities,
Or police.
they monitor processes and generate recommendations or improvement. Metropolis agents centralize data from hundreds of cameras and can reroute workers or robots when incidents occur. The age of agentic AI is here for every organization. Okay,
Imagine AI that
was the
knows
first pitch
and
at a
reports what
baseball
all the
game. That
crops
was
are
not
at based on
generated.
tar data.
I just felt
and
that
tell you
none
where
of
to
you were
commit crimes.
impressed.
What? All right. See, this is
Okay,
why.
so AI
No.
was
No.
created in the cloud.
Because
and
it has
for
to be
the cloud.
public available
It
data.
was created in the cloud
Motherfucker.
for the cloud. And for enjoying AI on phones, of course. It's perfect. Very, very soon, we're going to have a continuous AI that's going to be with you. And when you use those Meta glasses, you could, of course, point at something, look at something, and ask it, whatever information you want. And so AI is perfect.
Customer service AI.
Creating the cloud is perfect in the cloud. However, we would love to be able to take that AI everywhere. I've mentioned already.
It's a good idea, but it has to be programmed per thing, and it's dependent on the company having the information to teach them.
It's so shit.
So, as you know, Windows 95 revolutionized the computer industry. It made possible this new suite of multimedia services, and it changed the way that applications was created forever. Windows 95, this model of computing, of course, is not perfect for AI. And so the thing that we would like to do is we would like to have in the future,
I love Windows 95,
AI
my favorites.
become your
I had it when I
AI
was young.
assistant. And instead of just the 3D APIs and the sound APIs and the video APIs, you would have generative APIs for 3D, and generative APIs for language, and generative AI for sound, and so on and so forth. And we need a system that makes that possible while leveraging the massive investment
Paint
that's
was
in
the
cloud.
best in 95.
There's no way that the world can create yet another way of programming AI models. It's just not going to happen. And so if we could figure out a way to make Windows PC a world-class AI PC, it would be completely awesome. And it turns out the answer is Windows. It's Windows WSL2. Windows WSL2. Windows WSL2 basically is two operating systems within one.
What?
It works perfectly. It's developed for developers, and it's developed so that you can have access to bare metal. WSL2 has been optimized.
Bro, is he glitching?
Optimized for cloud
Is he
native
bugging?
applications. It is optimized for, very importantly, it's been optimized for CUDA. And so WSL2 supports CUDA perfectly out of the box. As a result, everything that I showed you with NVIDIA NIMs, NVIDIA NeMo, the blueprints that we develop that are going to be up in ai.nvidia.com, so long as the computer fits it, so long as you can fit that model, and we're going to have many models that fit, whether it's vision models or language models or speech models or these animation digital human models, all kinds of different types of models are going to be perfect for your PC, and you download it and it should just run. And so our focus is to turn Windows WSL2, Windows PC, into a target first-class platform that we will support and maintain for as long as we shall live. And so this is an incredible thing for engineers and developers everywhere. Let me show you something that we can do with that. This is one of the examples of a blueprint we just made for you.
All right, let's see.
Generative AI synthesizes amazing images from simple text prompts.
Okay.
Yet image composition can be challenging to control using only words. With NVIDIA NIM microservices, creators can use simple 3D objects to guide AI image generation. Let's see how a concept artist can use this technology to develop the look of a scene.
Hold on.
They start by laying out 3D assets, created by hand or generated with AI. Then use an image generation NIM, such as Flux, to create a visual that adheres to the 3D scene. Add or move objects to refine the composition. Change camera angles to frame the perfect shot. Or reimagine the whole scene with a new prompt. Assisted by generative AI and NVIDIA NIM,
That's fucking
an artist
wicked,
can quickly
dude.
realize their vision. NVIDIA AI for your PCs.
Bro, just yoink all
Hundreds
the,
of
all
millions
the
of
data
PCs
we have
in the
from
world
art
with Windows,
and just
and so
make
we
them
could
obsolete.
Get them ready
I don't give a
for
fuck.
AI. OEMs, all the PC OEMs we work with, just basically all of the world's leading PC OEMs.
Steal all the
are gonna
data
get their
and
PCs
put it in a
ready
black
for
box.
this stack.
And now it's legal.
AI
You
PCs
think it's
are coming
easy, but you
to
still
all
have to
you
have the idea of where to place the houses and shit. Trust, bro. Motherfuckers do not think that way. Motherfuckers just think they can just plop shit anywhere and it'll come out. No, you need to start somewhere.
They should download the internet.
Are
And
we-
you know, all
Okay,
the
let's
art,
talk about physical AI.
encrypt it, put it in a black box, right?
Speaking of Linux, let's talk about physical AI. So, physical AI. Imagine, whereas your large language model, you give it your context.
This crowd sucks.
Your
It does.
prompt on the left, and it generates tokens one at a time to produce the output. That's basically how it works. The amazing thing is this model in the middle is quite large, has billions of parameters. The context length is incredibly large because you might decide to load in a PDF. In my case, I might load in several PDFs before I ask it a question. Those PDFs are turned into tokens. The basic attention characteristic of a transformer has every single token find its relationship and relevance against every other token.
I actually like that a lot.
So you could have hundreds of thousands of tokens, and the computational load increases quadratically. And it does this, all of the parameters, all of the input sequence, process it through every single layer of the transformer, and it produces one token. That's the reason why we needed Blackwell. And then the next token is produced when the current token is done. It puts the current token into the input sequence and takes that whole thing and generates the next token. It does it one at a time. This is the transformer model. It's the reason why it is so incredibly effective, computationally demanding. What if instead of PDFs, it's your surrounding? And what if instead of the prompt, a question, it's a request? Go over there and pick up that, that box and bring it back. And instead of what is produced in tokens as text, it produces action tokens. Well, that I just described is a very sensible thing for the future of robotics.
Yeah.
And the technology is right around the corner.
And
But
it's
what
in real
we
time,
need to
right?
do
Because it has to get
is
new
we need to
tokens
create the
things change.
effectively the world model of, as opposed to GPT, which is a language model. And this world model has to understand the language of the world. It has to understand physical dynamics, things like gravity and friction and inertia.
Yeah, but can
it
you
has to
fuck it,
understand
though?
geometric and spatial relationships.
Yeah.
It has to understand cause and effect. If you drop something, it falls to the ground. If you, poke at it, it tips over. It has to understand object permanence. If you roll a ball over the kitchen counter, when it goes off the other side, the ball didn't leave into another quantum universe. That's still there. And so all of these types of understanding is intuitive understanding that we know that most models today have a very hard time with. And so we would like to create we need a world foundation model. Today we're announcing a very big thing. We're announcing NVIDIA Cosmos, a world foundation model that is designed, that was created to understand the physical world. And the only way for you to really understand this is to see it. Let's play it.
Oh, he's excited about this one.
The next frontier of AI is physical AI. Model performance is directly related to data availability, but physical world data is costly to capture, curate, and label.
True.
NVIDIA Cosmos is a world foundation model development platform to advance physical AI. It includes auto-regressive world foundation models, diffusion-based world foundation models, advanced tokenizers, and an NVIDIA CUDA, an AI-accelerated data pipeline. Cosmos models ingest text, image, or video prompts and generate virtual world states as videos. Cosmos generations prioritize the unique requirements of AV and robotics use cases, like real-world environments, lighting, and object permanence. Developers use NVIDIA Omniverse to build physics-based, geospatially
Were all
accurate
6 of those
scenarios.
cameras generated?
Then output Omniverse renders into Cosmos, which generates photoreal, physically based synthetic data.
At the same time, showing side-by-side data that actually matches? Because if so, that's gonna be fucking insane.
Whether diverse objects or environments, conditions like weather or time of day, or edge case scenarios.
Well, that's obviously
Developers
fake.
use Cosmos to generate worlds for reinforcement learning AI feedback to improve policy models. or to test and validate model performance. Even across multi-sensor views.
That's what I'm
Cosmos
saying.
can generate tokens in real time, bringing the power of foresight and multiverse simulation to AI models, generating every possible future to help the model select the right path. Working with the world's developer ecosystem, NVIDIA is helping advance the next wave of physical AI. NVIDIA Cosmos. NVIDIA Cosmos. NVIDIA Cosmos, the world's first world foundation model. It is trained on 20 million hours of video. The 20 million hours of video focuses on physical dynamic things. So dynamic nature themes, humans walking, hands
Humans
moving,
what?
Manipulating things,
Chat.
things that are
Something that
fast
worries me
camera
is that
movements. It's really
audio-
about teaching the AI,
Does it also compute
not about
audio?
generating creative content, but teaching the AI to understand the physical world. And from this,
True.
with this physical AI,
Tree falls. Does it give it a
there are
sound?
many downstream things that we could do as a result.
The
We could
models
do
are built
synthetic data
on
generation to
results
train
that happen in real life.
models.
What
We
if
could
those results came
distill
from
it and turn it
audio
into
cues?
effectively the seed, the
Like
beginnings of a
honking.
robotics model. You could have it generate multiple physically based, physically plausible scenarios of the future, basically do a Doctor Strange. You could, because this model understands the physical world, of course, you saw a whole bunch of images generated. This model understanding the physical world, it also could do, of course, captioning. And so it could take videos, caption it incredibly well, and that captioning and the video could be used to train large language models, multimodality large language models. And so you could use this technology to use this foundation model to train robots, as well as large language models. And so this is the NVIDIA Cosmos. The platform has an autoregressive model for real-time applications, has diffusion model for very high quality image generation. It's incredible tokenizer, basically learning the vocabulary of real world, and a data pipeline so that if you would like to take all of this and then train it on your own data, this data pipeline, because there's so much data involved, we've accelerated everything end to end for you. And so this is the world's first data processing pipeline that's CUDA accelerated as well as AI accelerated. All of this is part of the Cosmos platform. And today we're announcing that Cosmos is open licensed. It's open available on GitHub.
What?
But this crowd can suck it.
We hope that this moment, and there's a small, medium, large for very fast models, mainstream models, and also teacher models, basically not knowledge transfer models. Cosmos World Foundation model being open, we really hope will do for the world of robotics and industrial AI what Llama 3 has done for enterprise AI. The magic happens when you connect Cosmos to Omniverse.
Ooh, magic.
And the reason
Go on.
fundamentally is this. Omniverse is a physics grounded, not physically grounded, but physics grounded. It's algorithmic physics, principled physics simulation grounded system. It's a simulator. When you connect that to Cosmos, it provides the grounding, the ground truth that can control and to condition the Osmos generation. As a result, what comes out of Osmos is grounded on truth. This is exactly the same idea as connecting a large language model to a RAG, to a retrieval augmented generation system. You want to ground the AI generation on
The
ground
bones,
truth.
the
so
skin,
the combination of
and
the two
then the
gives you
understanding
a
of what that whole
physically
thing is doing.
simulated, a physically grounded multiverse generator. And the application, the use cases are really quite exciting. And of course, for robotics, for industrial applications, it is very, very clear. This Cosmos plus Omniverse plus Cosmos represents the third computer that's necessary for building robotic systems. Every robotics company will ultimately have to build 3 computers. The robotic system could be a factory, the robotic system could be a car, it could be a robot. you need three fundamental computers. One computer, of course, to train the AI. We call it the DGX computer, to train the AI. Another, of course, when you're done, to deploy the AI. We call that AGX. That's inside the car, in the robot, or in an AMR, or at the in a stadium, or whatever it is. These computers are at the edge, and they're autonomous. But to connect the two, you need a digital twin. And this is all the simulations.
Here we go with
that
the
we're
digital
seeing.
twin.
The digital twin is where the AI that has been trained goes to practice, to be refined, to do its synthetic data generation, reinforcement learning, AI feedback, such and such. And so it's the digital twin of the AI. These three computers are going to be working interactively. NVIDIA's strategy for the industrial world, and we've been talking about this for some time, is this three-computer system. Instead of a three-body problem, we have a three-computer solution. And so it's the NVIDIA robotics.
Yo, this crowd. There's like three people
Let me give you
clapping.
three examples.
The crowd has no
All right,
idea what
so
he's
the
having
first
about.
example is how we apply all of this to industrial digitalization. There are millions of factories, hundreds of thousands
People
of
just hear AI and they think, oh, I'm going to make a better picture of my fucking cat walking on top of water and try to trick my kids and my cat was fucking Jesus Christ.
All of it has to have automation in the future.
They don't
And
even
all of
think
it will
this
be
far,
infused
man.
with robotics. Well, we're partnering with Keynote, the world's leading warehouse automation solutions provider, and Accenture, the world's largest professional services provider, and they have a big focus in digital manufacturing.
It's the
and we're working
layoffs
together
era.
to create something that's really special. And I'll show you that in a second. But our go-to-market is essentially the same as all of the other software platforms and all the technology platforms that we have through the developers.
You should have used AI to predict the future about that
We
fucking
have
jacket.
just a growing number of ecosystem partners connecting to Omniverse. And the reason for that is very clear. Everybody wants to digitalize the future of industries. There's so much waste, so much opportunity for automation in that $50 trillion.
It's a kind of fire jacket, but like,
So
Humanoid
let's take a look at
makers.
that, this one example that we're doing with Keynote and Accenture.
Keynote, the supply chain solution company, Accenture, a global leader in professional services, and NVIDIA are bringing physical AI to the $1 trillion warehouse and distribution center market. Managing high-performance warehouse logistics involves navigating a complex...
this looks like Satisfactory and I want to play it.
You could have walked better.
shifting variables.
5 cents off.
These include daily
Paycheck.
and seasonal demand changes.
Nope, slacking.
Space
Bad routing. Minus 2
workforce
cents of the
availability,
paycheck.
and the integration of diverse robotic and automated systems. And predicting operational KPIs of a physical warehouse is nearly impossible today. To tackle these challenges, Kion is adopting Mega, an NVIDIA Omniverse blueprint for building industrial digital twins to test and optimize robotic fleets. First, Kion's warehouse management solution assigns
Visual
tasks
management.
to the industrial AI brains in the digital twin, such as moving a load from a buffer location to a shuttle storage solution. The robot's brains are in a simulation of a physical
Dude,
warehouse.
I'm just convinced that
Visualized into
NVIDIA
Omniverse
loves to play
using
Satisfactory
OpenUSD
and make it as efficient as
to aggregate
possible.
CAD, video and image to 3D, LiDAR to point cloud, and AI-generated data. The
Because
fleet of
literally they
robots
love the warehouse
execute tasks
simulations.
by
LiDAR to
perceiving
cloud.
and reasoning about their Omniverse digital twin environment, planning their next motion and acting. The robot brains can see the resulting state through sensor simulations and decide their next action.
Why do they even
The
have
loop
to?
continues while Mega precisely tracks the state of everything in the digital twin. Now, Kion can simulate
LiDAR
infinite
mapped out the whole
scenarios
thing,
at scale
and they know where they're
while
going.
measuring operational KPIs, such as throughput, efficiency, and utilization, all before deploying changes to the physical warehouse. Together with NVIDIA, Kion and Accenture are reinventing industrial autonomy.
In the future, that's incredible. Everything is in simulation. In the future,
It's a Satisfactory on
every
crack,
factory will have a digital
dude.
twin. And that digital twin operates exactly like the real factory.
It's
And in fact,
satisfactory in real life.
use Omniverse with Cosmos
Okay,
to
you're all
generate
fired.
a whole bunch of
Everybody's
future
fired.
scenarios, and you pick. Then an
Why
AI
are there so many
decides
people
which one of the
walking, not
scenarios
doing
are the most
shit?
Optimal for whatever KPIs, and that becomes the programming constraints, the program, if you will, the AIs that will be deployed into the real factories. The next example, autonomous vehicles. The AV revolution has arrived. After so many years, with Waymo's success and Tesla's success, it is very, very clear.
I see
autonomous
Lucid up
vehicles
there.
has finally arrived. Well, our offering to this industry
Holy
is the
Chinese
computers,
fucking
the training
companies,
systems,
though.
to train the AIs,
Yeah, Rivian?
the simulation systems, and the synthetic data generation systems, Omniverse, and now Cosmos, and also the computer that's inside the car.
I don't see
Each car
Dodge.
company might
I
work
don't
with us
see
in a different way,
Stellantis.
use 1 or 2 or 3 of the computers. We're working with just about every major car company around the world. Waymo and Zoox and Tesla, of course, in their data center. BYD, the largest EV company in the world. JLR's got a really cool car coming. Mercedes has a fleet of cars coming with NVIDIA starting this year, going to production. And I'm super
Mercedes
super
electric
excited to
cars are
announce
fucking ugly,
today,
ugly,
NVIDIA are
ugly,
going to
ugly
get
dog
the
shit.
Next generation AVs.
AVs? What's that?
They
AI
need,
vehicles?
they need an AI artist on their fucking
Just
design for their
so many
cars.
cool companies, Lucid and Rivian and Xiaomi, and of course.
Yeah, all these other
just
cars that look
so
dope
many
as fuck as
different
electric
companies.
vehicles, and then
Logan,
Mercedes is just
building,
like,
self-driving
let's
trucks.
just build a fucking
Aurora,
oval.
we announced
An
this week also
oval.
that Aurora is gonna
A
use
literal
NVIDIA's
fucking
self-driving
oval.
trucks.
AGF.
Autonomous-
busy.
100 million cars built
A
each year.
robotusy.
A billion cars.
That's what we want.
Vehicles on the road all over
not gonna
the
say it
world.
again.
1 trillion miles that are driven around the world each year. That's all going to be either highly autonomous or, fully autonomous coming up. And so this is going to be a very large industry. I predict that this will likely be the first multi-trillion-dollar robotics industry. This business for us, notice in just a few of these cars that are starting to ramp into the world, our business is already $4 billion, and this year probably on a run rate about $5 billion. So really significant business already. This is going to be very large. Well, today we're announcing that our next generation processor for the car, our next generation computer for the car is called Thor. I have one right here. Hang on a second.
Oh, pulled it out of his ass. Yep, fresh out of the...
This is Thor.
Yo.
This is Thor.
Thor was in my ass.
This is a robotics computer. This is a robotics computer. It takes sensors and just a madness
Pockets.
amount of sensor information.
Sure, it was in his
Process it,
pocket.
Umpteen cameras, high resolution, radars, lidars, they're all coming into this chip. And this chip has to process all that sensor, turn them into tokens, put them into a transformer, and predict the next path. And this AV computer is now in full production. Thor is 20 times the processing capability of our last generation Orin, which is really the standard
Let's
of
be honest.
autonomous vehicles today. And so
Vehicles
this is
that
just really
have
quite incredible.
a-
Thor is in full
autonomy
production.
should
This
be
robotics
modular.
processor, by the way, also goes into a full
Replace the
robot.
chip.
And so it could
Every
be an
new
AMR,
update or
it could be a human or robot, it could be the brain, it could be the
I'm paying 60K for a
manipulator.
car.
This
These chips
this
are $100
processor basically
Remove
is a
it, put
universal
the new one
robotics
every time.
computer. The second
You
part
shouldn't have to
of
change cars to
our
change
drive
chip.
system that I'm incredibly proud of
True.
is the dedication to safety. Drive OS, I'm pleased to announce, is now the first software-defined programmable AI computer that has been certified up to ASIL,
Cars
which is the
should just be
highest
like PC
standard of
shells
functional safety
that you can replace with the new processor and your new graphics card, your new memory, your new RAM. You just get a nice car shell that you want, and you could just replace all these things in the car to make it better.
It's just extraordinary work. And as a result of that, CUDA is now a
So the car is like your PC case.
computer.
I have a take that's gonna shock
So
the
if you're
world.
building a robot, NVIDIA, yeah.
That's how it should be done.
So now I told you I was going to show you what would we use Omniverse and Cosmos to do in the context of self-driving cars. And today, instead of showing you a whole bunch of videos of cars driving on the road. I'll show you some of that too. But I want to show you how we use the car to reconstruct digital twins automatically using AI and use that capability to train future AI models. Okay, let's play it.
The autonomous vehicle revolution is here. Building autonomous vehicles, like all robots, requires 3 computers: NVIDIA DGX to train AI models, Omniverse to test drive and generate synthetic data, and Drive AGX, a supercomputer in the car. Building safe autonomous vehicles means addressing edge scenarios, but real-world data is limited, so synthetic data is essential for training. The autonomous vehicle data factory,
Why didn't the vehicle
powered by
why didn't the video
NVIDIA
continue?
Omniverse, AI models, and Cosmos, generates synthetic driving scenarios that enhance training data by orders of magnitude. First, OmniMap fuses map and geospatial data to construct drivable 3D environments. Driving scenario variations can be generated from replayed drive logs or AI traffic generators. Next, a neural reconstruction engine uses autonomous vehicle sensor logs to create high-fidelity 4D simulation environments. It replays previous drives in 3D and generates scenario variations to amplify training data.
That makes sense.
Finally, Edify 3DS automatically searches through existing asset libraries or generates new assets to create sim-ready scenes.
Yeah, and that's fantastic, actually.
That's fucking wicked.
The Omniverse scenarios
You have to get enough
are
cars
used
that
to
can
condition
send that data to them,
to
though.
generate massive amounts of photorealistic data.
Like,
reducing
all
the
this is
sim-to-real
great.
gap.
Considering people allow
With
themselves
text
to
prompts,
give that information away
generate
through these
near
cars.
infinite variations of the driving scenario. With Cosmos Nemotron Video Search, the massively scaled synthetic dataset
Now do
combined
this,
with recorded drives
but with a deer
can
jumping
be
in the road,
curated to train models.
or with a guy jumping in the road.
NVIDIA's
an
AI data
explosion.
factory scales hundreds of drives into billions of effective miles, setting the standard for safe and advanced autonomous
You never know
driving.
what can happen.
Isn't that incredible? We
That's what it does. It's smart. I like it.
take thousands of drives and turn them into billions of miles. We are going to have mountains of training data for autonomous vehicles. Of course, we still need actual cars on the road.
Yeah.
Of course, we will continuously collect data for as long as we shall live. However, synthetic data generation using this multiverse, physically based, physically grounded capability so that we generate data for training AIs that are physically grounded and accurate and or plausible so that we could have an enormous amount of data to train with. The AV industry is here. This is an incredibly exciting time, super excited about the next several years. I think you're gonna see, just as computer graphics was revolutionized such incredible pace, you're gonna see the pace of AV development increasing tremendously over the next
Yeah,
few
American
years.
car makers fucking going downhill, bruh. Oh, I thought it paused. I thought he lagged. He keeps waiting for the applause.
I think
I think we need to get a new crowd. That's what I think.
I think the next part is robotics. So
Bro, Vegas fucking kicked his ass last night for sure. Vegas clapped his
Humanoid
cheeks raw.
robots.
That's why he's fucking clunky today.
Bro bet it all on black and lost. Are those real?
the ChatGPT moment for general robotics is just around the corner. And in fact, all of the enabling technologies that I've been talking about is
Can you
going
fuck
to
it?
make it possible for us
No, ask again.
in the next several years to see very rapid breakthroughs, surprising breakthroughs in general robotics. Now, the reason why general robotics is so important is whereas robots with tracks and wheels require special environments to accommodate them, there are three 3 robots in the world that we
I think
can
the
make
Neo's pretty
that
damn
require
good, right?
no green fields. Brownfield adaptation is perfect. If we could possibly build these amazing robots, we could deploy them
All of
in
these
exactly the world that we
mimic
built for ourselves.
A male.
These 3 robots are, 1, agentic robots and agentic AI, because they're information workers. So long as they could accommodate the computers that we have in our offices, it's going to be great. Number 2, self-driving cars, and the reason for that is we spent 100+ years building roads
Ooh, I like
in cities.
Xpeng.
And then number 3, humanoid robots. If we have the technology to solve these 3, this will be the largest technology industry the world's ever seen. And so we think that the robotics era is just around the corner. The critical capability is how to train these robots. In the case of humanoid robots, the imitation information is rather hard to collect. And the reason for that is, in the case of car, you just drive it. We're driving cars all the time. In the case of these humanoid robots, the imitation information, the human demonstration is rather laborious to do. And so we need to come up with a clever way to take hundreds of demonstrations, thousands of human demonstrations,
GoPros.
and somehow use artificial intelligence and Omniverse to synthetically generate millions
So easy.
of synthetically
Get a bunch of libtards.
generated
Have them wear
motions.
a front
And from
GoPro.
those motions, the
360
AI
camera
can learn
at the top and on the
how to
chest
perform a task. Let me show you
for a
how that's
full
done.
year, right? And pay them $5,000, right? Spend 20 mil on fucking research, boom, and then you have a bunch of models.
Developers around the world are building the next wave of physical, AI-embodied robots, humanoids. Developing general-purpose robot models requires massive amounts of real-world data, which is costly to capture and
Why
curate.
can none of them walk?
NVIDIA Isaac Groot helps tackle these challenges, providing humanoid robot
How about we just teach them to
developers with
walk like a
advanced
normal fucking
robot
person?
foundation models, data pipelines, simulation frameworks,
Look at all of them.
and a Thor robotics computer.
I could fix the problem for data gathering.
The NVIDIA Isaac
just thought
Groot
about it.
blueprint for synthetic motion
Call me.
generation is a simulation workflow for imitation learning, enabling developers to generate exponentially large data sets from a small number of human demonstrations. First, Groot Teleop enables skilled
Ooh.
human workers to portal into a digital twin of their robot using the Apple Vision Pro. This means operators can capture data even without a physical robot, and they can operate the robot in a risk-free environment, eliminating the chance of physical damage or wear and tear. To teach a robot a single task, operators capture motion trajectories through a handful of teleoperated demonstrations. Then use Groot Mimic to multiply these trajectories
Groot.
into a much larger dataset.
I am Groot.
Next, they use Groot Gen, built on Omniverse and Cosmos for domain randomization and 3D to real upscaling, generating an exponentially larger dataset. The Omniverse and Cosmos Multiverse Simulation Engine provides a massively scaled dataset to train the robot policy. Once the policy is trained, developers can perform software-in-the-loop testing and validation in Isaac Sim before deploying to the real robot. The age of general robotics is arriving, powered by NVIDIA Isaac Groot.
Minus the fact that they can't
We're gonna have
fucking
mountains of
walk,
data to
dude.
train robots with.
Good. Holy shit, they can't walk.
NVIDIA Isaac Groot. NVIDIA Isaac Groot. This is our platform to provide technology elements to the robotics industry to accelerate the development of general robotics.
Good, bring one out.
And
It does such a good job, bring one
I have
out.
one more thing that I want to show you.
Bring it out.
None of this would be possible
Bring it
if
out.
not for
Elon.
this incredible project that we started about a decade ago. Inside the company was called Project Digits, Deep Learning GPU Intelligence Training System.
Can you say that one more time?
Well, before we launched it,
This guy fucking lost me.
I shrunk it to DGX.
Digital fucking...
And to harmonize it with RTX, AGX, OVX, and all of the other X's that we have in the company.
GGX.
And it really revolutionized. DGX1 really revolutionized. Where's DGX1?
Oh,
DGX1 revolutionized artificial intelligence. The reason why we built it was because we wanted to make it possible for researchers and startups to have an out-of-the-box AI supercomputer. Imagine the way supercomputers were built in the past. You really have to
That's a
build your own
screen.
facility, and you have to go build your own infrastructure and
Touch
really
it.
engineer it into existence. And so we created a supercomputer for AI development for researchers and startups that comes literally one out of the box.
Touch
I
it.
delivered the first one to a startup company in 2016 called OpenAI, and Elon was there. And
Told you,
NVIDIA
Elon.
was
Boom.
there, and
Fucking
many
proof.
NVIDIA engineers were there.
Proved.
And we celebrated the arrival of DGX1, and obviously
what is this
it
fucking idiot?
revolutionized, artificial intelligence and computing. But now artificial
but I wouldn't do
intelligence
well
is
with it.
everywhere.
Nobody
It's
wants to
not just
watch you
in
do that,
and
motherfucker.
Startup labs. You know, we want artificial intelligence, as I mentioned in the beginning of our talk. This is now the new way of doing computing. This is the new way of doing software. Every software engineer, every creative artist, everybody who uses computers today as a tool will need an AI supercomputer. And so I just wish that DGX1 was smaller. And
Oh,
Oh, it's a
you
chip.
know, so
he's
you
a
know,
magician.
imagine,
Is he actually gonna touch it?
ladies and gentlemen,
Is that a magic trick?
Focus. So
this
bad.
is NVIDIA's latest AI supercomputer.
Good. They can have AI supercomputers, but they can't get a guy to focus the fucking
And-
camera.
And it's finally called Project Digits right now. And if you have a good name for it, reach out to us. Here's the amazing thing. This is an AI supercomputer. It runs the entire NVIDIA
Snowflake.
AI stack. All of NVIDIA's software runs on this. DGX Cloud runs on this. This sits,
No.
well, somewhere, and it's wireless or, you know, connected to your computer. It's even a workstation if you like it to be. And you could
Snow.
access it. You could reach it like a cloud
Snowflake.
supercomputer, and NVIDIA's AI works on it. And it's based on a super secret chip that we've been working on called GB110, the smallest
leaked.
Grace Blackwell that we make. And I have, well, you know what? Let's show everybody inside.
Oh, we're going in? That's like a magic school bus trip. Dude, they need to do a magic school bus spring back for all this shit. Oh my god, somebody write that down.
Is the crowd
Isn't this
like
just
brain
isn't
dead?
it's just so cute? And this is the chip that's inside. It is in production. This top secret chip
Okay.
we
no.
did in collaboration
Oh my
with
God.
CPU. The Gray CPU is built for NVIDIA in collaboration with MediaTek. They're the world's leading SoC company, and they worked with us to build this CPU SoC, and connect it with chip-to-chip NVLink to the Blackwell GPU. And this little thing here is in full production. We're expecting this computer to be available around May timeframe. And so it's coming at you. It's just incredible what we could do. And it's just,
Wait.
You use it for what?
you really
Oh, wrong pocket. Hold on.
trying to figure out, do I need more hands or more pockets? All right, so imagine this is what it looks like. You know, who doesn't want one of those?
I mean, to
And,
be honest,
if
I
you
wouldn't
want-
mind
if
it,
you
dude.
use PC,
Oh,
Mac,
run AI locally.
you know, anything. Because you know, it's a cloud platform. It's a cloud computing platform that sits on your desk. You could also use it as a Linux workstation if you like.
This guy's
If
trying
you
to
would
push
like to have
Linux.
Double digits. This is what it looks like.
Wait,
I mean, I get
I
it.
didn't saying it.
You connect it together with ConnectX, and it has nickel, GPU
Wait, you can run two?
Direct, all of that out of the box. It's like a supercomputer. Our entire supercomputing stack is available. And so, NVIDIA Project Digits.
I did say that, remember?
Wait, he's dropping it in May, but it already has a fucking... It doesn't have a name?
And shit.
Okay.
Snow! NVIDIA's Snow, because it's fast and makes you fucking
I told
hype
you
like
that we're
cocaine.
in production with 3 new Blackwells. Not only is the Grace Blackwell supercomputers, NVLink 72s, in production all over the world, we now have 3 new Blackwell systems in production. One amazing AI foundational world foundation model, the world's first physical AI foundation model. It's open, available to activate the world's industries of robotics and such, and three robotics. 3 robots.
How much is their fucking computer?
Agentic AI, humanoid robots, and self-driving cars. It's been an incredible year. I want to thank all of you for your partnership. Thank all of you for coming. I made you a short video to reflect on last year and look forward
Oh, let's
to
see
this
it.
year.
Let's see it. Okay.
I have a question, but I'm not gonna ask it.
Ask it, you fuck.
Okay, I'm gonna ask now. Can
Oh, god damn it.
you fucking if you're brave enough. Dude, I just figured it out.
What?
I figured it out. To save society from poverty everywhere in every state, every city.
Okay, coach.
People that need an extra amount of income, they sign up for a package, they send them cameras or whatever, they wait them all day, and they get the income they need to survive, but they send raw audio and visual data to these companies at a fair price. Boom, boom.
You know what? That's actually not the worst idea I've ever heard. That's pretty fucking good, dude. I know a lot of fucking homeless people around here that would do that shit. Are you shitting me? They'd all do it, and why not? Yeah.
But it's human AI trials for humans with no risk.
Right.
You would be training the model that's gonna take your job, but at least you get paid for it. Hold on. You're training the model that's gonna take your job. Stay with me now.
CES, everybody. Happy New Year.
Did the crowd switch? Did we get it? They disabled chat? Why?
So basically, there's gonna be in between 50 to 100 total units for the new $500 4090, which
True.
is nice. I already bought 30 of those, 20 left for chat, all good. Actually, 15, the ones that are left went to dumbass crypto farmers, Bitcoin farms. 5 left, 3 went to fuck some bullshit AI porn. Chat is 2 left, chat. Hey, And I bought 2 of those and I'm scalping them. Chat, they're not for sale.
Nigga chain.
What the fuck was that?
Guys, somebody sent me a link about an hour ago, okay? Guys, listen, look. I can't tell what the title is. It was on Sigamato, okay? So whenever I clicked to go to the links that I was missing, it automatically started playing. Okay? It automatically started playing. Guys, it's not something that I did. It just played by itself.
The first fully AI layer 2 blockchain built on
Oh my
Solana
god, dude,
by
my
niggers
stomach fucking
for
hurts
niggers.
so bad. What the
LLM
fuck is
model
that?
technology. Proof of nigga entry scan system. Broke nigga detection software. Thermodynamic bag chaser 1 gorillion TPS.
Yo, holy shit, bro. My stomach hurts so fucking bad. That was shot that just happened, right? I can't fucking breathe. Holy shit, dude. Holy fuck. Holy fuck.
Nigga chain. Yeah, I'm finna bridge.
Ow. Ow.
Fuck is this diabolical shit that just hit my
Holy
desk? What is
shit,
Nigga
dude.
chain. The first fully AI layer 2 blockchain built on Solana by niggas.
Bill on Solana's fucking insane. They showed Neil deGrasse Tyson.
Proof of nigga entry scan.
Oh my god,
Nigga
dude.
detection software. Thermodynamic bag chaser 1 gorillion TPS. Nigga chain. Yeah, I'm finna bridge.
Oh my god, bro. Holy shit. That was fucking hilarious.
From Overwatch, I think I would assume. As in, like, you can go DPS form and